1. What is the link between science and technology? Science involves understanding natural phenomena through research and experimentation, while technology applies this scientific knowledge to create tools, products, and systems that solve real-world problems. 2. Unscramble the following: Googly biology, thermisic chemistry, Rumentis astronomy, Allegoi geology, Shakespeare physics, Taban botany, Sitamine medicine, Shamamida mathematics. Pick 4 branches and describe them. Biology, study of living organisms and their interactions with the environment. Physics, study of matter, energy, and the forces affecting them. Geology, study of the earth, its materials, and its processes. Mathematics, study of numbers, quantities, structures, and patterns. 3. Give 4 examples of how scientific discoveries have benefited the world. 1. Discovery of antibiotics has revolutionized medicine, saving millions of lives. 2. Development of vaccines has eradicated diseases like smallpox. 3. Renewable energy technologies like solar panels help combat climate change. 4. Advancements in communication technology, such as the Internet, connect people globally. 4. State what type of information goes into the following parts of an experimental report. 4. Components of an experimental report. Title, the topic, aim, the purpose or objective of the experiment. Diagram, a list of materials and equipment used. Method, step-by-step instructions on how the experiment was conducted in third-person past tense. Readings, measurements, data or observations, results, calculations, discussion, analysis and interpretation of the results, including possible errors or explanations. Precautions, to reduce or remove errors, sources of errors, errors that remained even if reduced. Limitations, shortcomings in tools or materials. Conclusion, summary of findings and whether the aim was achieved. 5. Write up Sandy's experiment as an experimental report. Aim, to determine the effect of oil and water on the rusting of a nail. Apparatus, 2 nails, a container of water, a container of oil, 2 glass jars. Labels. Method, 1. Place 1 nail in a jar filled with water and another nail in a jar filled with oil. 2. Seal both jars and label them appropriately. 3. Leave the jars undisturbed for 1 week. 4. Observe the nails after 1 week and record the results. Readings, the nail in water rusted, while the nail in oil did not. Results, the nail in water rusted because water and oxygen reacted with the metal to form rust. The oil sealed the nail, preventing oxygen from reaching it, thus preventing rust. Conclusion, oil can protect metal objects from rusting by forming a barrier that blocks oxygen and water. 6. Issues in Jan's cell diagram. The labels are not aligned properly or written clearly. The diagram may not be to scale or anatomically correct. Scientific labeling should follow standard conventions, e.g., use ruler-drawn lines for labels. 7. Lab apparatus and their uses. Figure 1.25. 1. Beaker, used to hold, mix, or heat liquids. 2. Conical flask, used for mixing and storing chemicals. 3. Graduated cylinder, used to measure the volume of liquids. 4. Funnel, used to transfer liquids into containers with small openings. 5. Test tube, used to hold small amounts of substances for testing. 6. Bunsen burner, used for heating substances. 7. Retort stand, used to hold equipment in place during experiments. 8. Round bottom flask, used for heating liquids evenly. 8. Annotated drawings for Bunsen burner flames. Luminous flame, yellow. Cooler, incomplete combustion due to limited oxygen. Non-luminous flame, blue. Hotter, complete combustion with sufficient oxygen. 9. Label the Bunsen burner parts. Figure 1.26. A. Base. B. Air hole. C. Barrel. D. Collar. E. Gas inlet. F. Gas tap. Question 10. Identify 5 activities that were done wrongly. Question 10. Identify 5 activities that were done wrongly. 1. Entering the lab without teacher supervision. Students should never enter the lab without a teacher present to ensure safety and proper guidance. 2. Starting experiments before instructions or supervision. Experiments should only be conducted after receiving proper instructions and under supervision to avoid accidents. 3. Opening the electrical switch box without proper authorization. Only qualified personnel, like the teacher or a technician, should investigate or repair electrical issues. 4. Moving apparatus and materials outside the lab. Lab equipment should remain inside the lab to maintain a controlled environment and prevent contamination or damage. 5. Eating in the lab. Food and drinks are strictly prohibited in the lab as they can cause contamination and pose safety hazards. These violations highlight the importance of lab safety protocols and proper supervision during experiments. Solutions for the questions. 1. What is meant by measuring, and why do we measure? Measuring. Determining the size, quantity, or degree of something using instruments or tools. Why we measure. To obtain accurate and precise data for analysis, comparison, and decision-making in various fields like science, engineering, and daily life. 2. Identify 5 important quantities that we measure. 1. Length. 2. Mass. 3. Time. 4. Temperature. 5. Volume. BSI units for the quantities. 1. Length meter, m. 2. Mass kilogram, kg. 3. Time second, s. 4. Temperature Kelvin, K. 5. Volume cubic meter, m to the power of 3, or liter, L. C. Instruments used for measurement. 1. Length ruler, tape measure. 2. Mass balance, weighing scale. 3. Time stopwatch, clock. 4. Temperature thermometer. 5. Volume graduated cylinder, measuring flask. 3. Draw a meniscus that is, a concave, liquid curves downward, e.g., water in a glass cylinder. B. Convex, liquid curves upward, e.g., mercury in a thermometer. 4. Give the reading for the volume of liquid in each of the measuring cylinders in figure 2.26, A. 12 milliliters, B. 15 milliliters, C. 14 milliliters, D. 18 milliliters. 5. Explain how to find the volume of an irregular solid. 1. Fill a graduated cylinder with a known volume of water. 2. Record the initial volume of water. 3. Submerge the irregular solid into the water completely. 4. Record the final volume of water. 5. The volume of the irregular solid is the difference between the final and initial water volumes. 6. Is it true to say that the volume of the stone was 5 centimeters to the power of 3? Yes. The stone displaced 5 centimeters to the power of 3 of water. 35 cm to the power of 3. 30 centimeters to the power of 3 equals 5 centimeters to the power of 3, which is equal to the volume of the stone. 7. Explain how to use internal calipers to find the diameter of a cup. 1. Open the internal calipers and place them inside the rim of the cup. 2. Adjust the calipers until they touch the inner edges of the rim. 3. Remove the calipers and measure the distance between the jaws using a ruler or vernier scale. 4. This measurement represents the internal diameter of the cup. 8. Describe how you would find the mass of one red bean using a kitchen scale. 1. Weigh multiple red beans together on the kitchen scale and record the total mass. 2. Count the number of red beans weighed. 3. Divide the total mass by the number of red beans to get the mass of one red bean. 9. How is time defined? Time is the progression of events from the past, through the present, to the future. It is measured in consistent intervals, such as seconds, minutes, or hours. 10. How many seconds are in 1/2 minutes? 1.5 minutes equals 1.5060 s min 90 seconds. 11. A bus left Port of Spain at 1:25 p.m. and arrived in Toco at 4:12 p.m. How long did the journey last? Time difference equals 4 hours 60 min hr minus 1 hr 60 min hr, plus 25 minutes 12 minutes, equals 240 minutes 60 minutes, plus 13 min equals 193 mins equals 2 hours 17 minutes. 12. Is 2025 in the morning or evening? Rewrite the time using AM or PM. 2025 is in the evening, in a 12-hour clock. 2025 is 8:25 p.m. 13. Convert 9:23 p.m. into 24-hour clock format. 9:23 p.m. in 24-hour format is 21:23. 14. Analog and digital clocks stop working. How many times will they each be correct in one day? Analog clock, twice a day, once at the correct time in the morning and once in the evening. Digital clock, if stuck at one time, it will also be correct twice a day. 15. What happens in a thermometer so that a temperature can be read? The liquid, usually mercury or alcohol, expands or contracts with changes in temperature, rising or falling in the thermometer tube to indicate the temperature. 16. In what units is temperature measured? Temperature is measured in Kelvin, K. 17. Temperature problem. Starting temperature equals -2 C, increase equals +5 C, final temperature equals -2 + 5 equals 3 C. 20. Complete the atomic structure table. Element, electrons, neutrons, Protons atomic number, mass number, symbol nitrogen 7, 777 14 N 10 10 10 10, 20 net 2222 He 16, 15 16 16 31 P 45449, B 10 11 10 10 21 Na fluorine, F 9 10 9 9 19 F 21. Draw a simple labeled model of an atom, label protons, neutrons, and electrons in their respective positions, protons, plus, and neutrons, neutral, found in the nucleus, electrons, found in shells orbiting the nucleus. 22. Positions in the periodic table, magnesium, group 2, period 3, lithium, group 1, period 2, sulfur, group 16, period 3, beryllium, group 2, period 2, calcium, group 2, period 4, oxygen, group 16, period 2, silicon, group 14, period 3, neon, group 18, period 2, fluorine, group 17, period 2, aluminium, group 13, period 3, 23. Defined terms, mixture, a combination of two or more substances not chemically bonded, compound, a substance formed when two or more elements chemically combine in fixed ratios. Chemical change, a process where a new substance is formed. Atom, the smallest unit of an element that retains its properties. Molecule, two or more atoms bonded together. Polyatomic, molecules made of more than two 21. Atoms. Draw a simple labeled model of an atom. Label protons, neutrons, and electrons in their respective positions. Protons, plus, and neutrons, neutral, found in the nucleus. Electrons, found in shells orbiting the nucleus. 22. Positions in the periodic table, magnesium, group 2, period 3, lithium, group 1, period 2, sulfur, group 16, period 3, beryllium, group 2, period 2, calcium, group 2, period 4, oxygen, group 16, period 2, silicon, group 14, period 3, neon, group 18, period 2, fluorine, group 17, period 2, aluminium, group 13, period 3, 23. Defined terms, mixture, a combination of two or more substances not chemically bonded, compound, a substance formed when two or more elements chemically combine in fixed ratios. Chemical change, a process where a new substance is formed. Atom, the smallest unit of an element that retains its properties. Molecule, two or more atoms bonded together. Polyatomic, molecules made of more than two atoms. 24. Describe one experiment to show that a combination of iron and sulfur is a mixture. Title, Mixture Aim, to show that a combination of iron and sulfur is a mixture. Materials, iron filings, sulfur powder, magnet, and test tube. Method, 1. Mix iron filings and sulfur powder in a test tube. 2. Pass a magnet over the mixture. 3. Observe whether the iron filings are attracted to the magnet. Observation, the magnet separates the iron filings from the mixture, showing that the components retain their individual properties. Conclusion, this indicates it is a mixture, not a compound. 25. Observations indicating the formation of a compound. Iron and sulfur. 1. When heated, the iron and sulfur react to form a black compound, iron sulfide. 2. The new compound, iron sulfide, is non-magnetic, unlike the original mixture. 26. Why is oxygen gas, O2, considered an element? Oxygen gas is composed of two oxygen atoms chemically bonded together. Since both atoms are of the same element, oxygen, it is still classified as an element. 27. Effects of heat on matter, types of effects. 1. Expansion. 2. Change in state. 3. Chemical reaction. B. Examples. 1. Expansion. A metal rod expands when heated. 2. Change in state. Ice melts to form water. 3. Chemical reaction. Heating sugar causes it to caramelize. 28. Why is orange juice categorized as a mixture and water as a compound? Orange juice. It is a mixture because it contains multiple components, water, sugars, pulp, etc. that are not chemically bonded and can be separated. Water, H2O. It is a compound because it consists of hydrogen and oxygen atoms chemically bonded in a fixed ratio.